In the previous lecture, we saw how we can move a component to a target position. So whenever we tap on the screen, and in this case, in this example or in this diagram, this is the target position, or the user would tap at this point, which is 200 by 100. And this is our component with the current position of 400 and 700. And to move this component to the target point, we first calculated the direction vector by subtracting current position of the component from the target vector, a target position. And in this process, we get a direction vector of something like that, to minus 200 by minus 200 and minus 600. And then we normalized that direction vector. So if you are not familiar with this normalized thing, or if you really don't know why we need to convert this vector to a unit vector, then I think I should say more about it. But if you are familiar with that, if you know vector well, if you know a unit vector, if you know about normalized, why we normalize this vector to get the accurate direction, so that we can have a consistent speed, then you can easily skip this lecture and go to the next one. So why did we actually normalize this vector? I told you that we needed to convert this direction vector to a unit vector where the x value and y value will be 1 or near to 1. Why we need that? I told you that we're not interested in the value of corresponding x's. We are only concerned about the direction. So what if we don't normalize? What if we directly assign this direction vector to the velocity? So let's go to our code, and inside our myRectangle component, inside this move to target method, after we calculated the direction, then we normalized the direction and assigned it to the velocity. So what if we don't do this? What if I don't do this? So in this case, the value of x-axis and y-axis of this direction vector would be minus 200 or 600 or a lot bigger values. So in that case, you know that this velocity is being added by with the position continuously with every update method call. So if the value of x and y is greater than 1 or a higher value, then multiplying this vector with this scalar and this scalar would result a much higher speed that we can control. So if I run this example without this normalization, and if I click somewhere else, look very carefully what happens. So if I click, and you see that our position component just vanished, and we just saw a glimpse of that position component that's moving towards that point, but the speed was so fast. Okay, so that's why we need to normalize that. So the higher the distance between the target and the position component, the higher the speed will be. For example, if I restart again and then I click near to this rectangle component, for example here, then you'll see the speed is a bit slower than the previous one, but still it is very fast. That means if we don't normalize, then depending on the distance from the target to the, or from the component to the target, the speed would vary. And to provide a consistent speed, that's why we needed to normalize this vector. We needed to normalize this vector by calling this normalized method. So what it do is it will reduce the value of x and y near to 1 by respecting the direction. So in our image, the direction vector over here, what we get from here, the direction vector would point to this one. So this is the direction vector. This is the point over here. So this is pointing over here. So this is the direction vector. And after normalization, the vector would be very little. I mean, to x, towards the x or minus x, it would be minus 0.94, perhaps this one over here, or very little portion or offset, and towards the y-axis, negative y, that would be minus 0.31. I mean, that would be somewhere like here. So this and this. So you see, after normalization, the X value and Y value is reduced, but the direction still the same. So now it is also pointing upwards to this target position, and that's what we exactly need. We only need the direction, not the actual value of X and Y. That's why we need to normalize. And since this will act like a unit vector, so whatever speed we add or whatever speed we provide, whatever scalar we add, the speed will be consistent across the game.